Good morning, folks. Welcome to today's office hours on Oracle Database InMemory. We'll begin the session at the top of the hour at 10 a.m. Pacific time, 5 p.m. UCT. Just bear with us. In today's session, what we're going to cover is Oracle Database InMemory running in a RAC environment. This is part 2 of this topic. If you haven't already, you can check out our previous AskTOM Office Hours on Oracle Database InMemory on RAC by going to the asktom.oracle.com website. So all of your lines are currently muted. If you need to ask a question, feel free to use the chat option at the bottom of your screen. If you just click on the chat, you can send it directly to Andy or I, Maria Colgan, or you can just send it to everyone and we'll make sure that those questions get answered during the course of the webcast. Bear with us, we're just waiting for Andy, our co-presenter, or my co-presenter, to join. And as I said, we'll get going at the top of the hour. Speak of the devil, it looks like Andy has just joined us. So for folks that are just joining us, we will start our next AskTOM Office Hours on Database InMemory in just a moment. We're just going to wait for the top of the hour and for folks who may need or want to join us. And then Andy Rivenes is going to kick us off with a little bit of background on running Database InMemory on a RAC cluster. If you do have any questions right now, all of your lines are mute, but you can ask those questions via the chat function. You'll find a little white bubble for the chat at the bottom of your screen. If you click on that, you can either send a question directly to myself or Andy, or you can send it to everyone, and we'll try and make sure that we address all of those questions throughout the course of the session. So Andy, I make it 10 on the dot. Do you want to get started?
Yeah, let's go ahead and get going. So my name's Andy Rivenes. I'm a product manager with Database InMemory, and we also have Maria Colgan, SQL Maria, who kind of does everything with Oracle Database. And so hopefully we can answer all of your questions. This is going to be essentially RAC Part 2. The last time we did RAC Part 1 and talked about how Database InMemory works with RAC. And we're going to continue on to that. I'll do a little review, but what we're going to focus on are services and how they interact with both Active Data Guard and then RAC, with allowing you to run essentially a subset of column stores or perhaps even isolated column stores. And so we're kind of going to go through that and finish off the information about RAC. So with that, we'll get started. We have our safe harbor statement, although I don't think we're going to talk about anything that would need to be covered by that. But let's do a little bit of review with from what we talked about in the previous session. Again, this is Part 2. In Part 1, we talked about how RAC enables scale out with Database InMemory. And so what we can do, since we're essentially running in memory, our SGA is limited to the amount of memory we can allocate on a single node. With RAC, since we have multiple nodes in a cluster, we can actually scale out Database InMemory across those multiple nodes. In this case, my example here on the slide, I've got 4 nodes. And so if you were able to allocate, say, 500 gigabytes of column store on a single node and you needed more than that on a RAC database, in this case, you could have 2 terabytes of column store because it would be allocated across all 4 nodes. Something to remember is that the column store, in order to support scale out, it essentially is a shared nothing environment. So we distribute data across all 4 nodes in order to increase the ability or the amount of memory in the column store from, again, in this example, 500 gigabytes to 2 terabytes. But we don't ship IMCUs across the interconnect. So unlike cache fusion or database blocks where we would, in normal RAC in the row store, we would ship those blocks across the interconnect to the instance accessing them. We don't do that with Database InMemory. So in order to access that data on the other nodes, and we'll go into this a little bit more in more detail, we have to run parallel query. And so we run parallel server processes on each node to access that data, and we only return the resulting rows rather than all of the data across the interconnect. This makes it very efficient, and again, supports that ability to have scale out. And then we talked a little bit about the ability to do distribution. So if we're going to scale and move or have an object distributed across all of these nodes, since we said they were shared nothing, we have to have a way to control that. And so we have the distribute subclause as part of the alter table or create table in memory. And so we have, by default, Oracle will pick the way it wants to distribute that data, either by row ID range, partition, or subpartition. Distribute auto is the default. Otherwise, you can actually control it, because it wouldn't be Oracle if we didn't give you lots of ability to control things. And so you can decide that for, say, partitioned or subpartitioned tables, that you want to distribute those by partition or subpartition rather than by row ID range, which is basically the normal way, certainly for materialized views or tables. It's the only way to distribute that data. And the idea, again, being that we're going to query that data across the column store. The idea also, since it's parallel query that's accessing the data, we want that data to be as evenly distributed across the column stores as possible. We don't want a set of parallel query processes running for a very long time because the data is skewed and 80 or 90% of the data is on one node and only a small amount of data is on the other nodes. We want it to be fairly evenly distributed, which is kind of how we control which option we decide to use in the automatic nature, such that we get the query to finish, and it's not gated on any particular node. We get all of the queries to finish, or all of the scans, I should say, across the column store to finish in essentially the same amount of time. And so that gives us the best performance and also gives us the best memory distribution across the rack cluster. And then kind of a picture in our 4-node example, in order to, as I said, in order to access this data across all 4 of the column stores, as in our example, we do use parallel query, which implies that since we're using parallelism, that the degree of parallelism, or the DOP, has to be at least as great as the number of column stores. And as we need to get at least one parallel server process scheduled for each of the column stores in order to access that data. I have a little note here that in 12.102, this required that you enable auto DOP. And auto DOP is a great way to automatically let the optimizer decide the degree of parallelism. However, some folks will have trouble in higher concurrency environments with auto DOP, and even though they might use Resource Manager to control CPU utilization, they don't want to use auto DOP. And so in 12.2, we relaxed that condition, and we said, well, you still have to have a DOP at least as great as the number of column stores, but we'll let you manually pick the DOP if you choose to, so that you don't have to use auto DOP to achieve the same results. And so there is the ability to do that. But we still, basically, best practice is recommended is to use auto DOP, because otherwise you've got a set DOP, and it's letting the Oracle database do that is typically more efficient. And that leads us into distribute for service. So then we'll talk about services. So that's kind of the background of, in a few short slides, what we spent quite a bit of time in the first rack session talking about. If you're interested in any of that, we not only have blog posts to talk about this, we have a whole series of blog posts to talk about rack. You can also go back and look at the video for the previous Ask Tom session and all our other videos. That's kind of a plug to, you can go back and look at that if you find any of this interesting, or you want to review, maybe you didn't catch the first parts of how Database InMemory works, the issue of talking about that Database InMemory is really geared towards analytic queries, columnar formatted data, and how we do all that in Oracle Database. You can go back and look at some of the previous sessions to catch up.
And so, Andy, where would I find those sessions?
So those are on the AskTOM website. The link or the link for the page that you joined the session with has those right on it. So that's kind of your portal into AskTOM for Database InMemory, is that the message, the email you got sent out to saying to join our session today also has all of those links on it. So distribute for service. So I showed you the distribute subclause. We added in 12.2 the ability to put a for service option on that. And what that essentially allows you to do is to associate objects with a particular service. And then you can associate those services with column stores or in a rack environment, and so that you can then populate that data in one or more column stores. And we're going to talk a little bit about that. We also did it to support Active Data Guard. So we needed a way to ensure that in the different scenarios, which I'll go over in a few minutes, that you could target objects to be in one or both of your Active Data Guard, either the primary or the standby or both. And so it serves kind of a dual purpose. By default, you get the pre-12.2 behavior, which means we intend to distribute to basically all of the column stores, treat it as a normal scale-out environment. But we, again, since we give you choices, we do allow you to run on a subset of column stores or nodes in rack, and we'll talk a little bit about why you might want to do that. And also, allow you to have more flexibility in targeting objects in a primary standby data guard environment. And I have all of the syntax. We support the service name itself. We honor priority. You can still do on demand. And so we have these options to the command, but you can go look in the reference manual and look at all of the ways to make use of it. Also in our in 12.2 and above with our Database InMemory guide, we have our own documentation guide now. We have some examples there as well, and then I did mention our blog posts in addition to that. And then we're going to talk about it right now, how you can make use of the distribute subclause. So with that, we're going to jump in just a couple slides on Active Data Guard, since we're really focused on rack, but I would be doing a disservice if I didn't mention the Data Guard abilities of the for service command. So I'll just quickly review that, and then we'll move on to back to rack. So in an Active Data Guard environment, prior to 12.2 and 12.1, the initial release of Database InMemory 12.102, you could allocate the column store on the standby database, but you couldn't populate it. In 12.2, we allow you now to populate objects in the standby database, or rather than just in the primary database. And so by default, we'll populate any object that's alter table in memory will get populated. If you've allocated a column store on the standby as well, will get allocated to both environments. And this is actually of some value to folks that are running reporting instances or reporting activity workload on the standby database, because you can now offload the analytic reporting from your primary database to your standby database. So not only could you do normal reporting from the row store on your standby database, you can now do analytic reporting and get tremendous speed up and benefits on the standby database as well, rather than having it limited and not being able to do that. So that's kind of the motivation for allowing population of the column store on a standby database. So again, in-memory size parameter will be set on both the standby and the primary. Then by default, all objects marked in memory will be populated in both the standby and or the primary and the standby. Whoops. And then you can also just allocate the column store on the standby. Say you didn't want to have analytic reporting done on your production system. Maybe you're trying to keep it pure OLTP. You don't want mixed workload. You don't want analytics run there. You'd rather take that workload and for the capacity availability on the standby site and use it there. So then you could allocate the column store in memory underscore size only on the standby. then all objects, obviously, since the standby is essentially read-only, any alter table command in memory run on the production system then would populate to the standby database. And so since you didn't have a column store in the production or the primary side in this example, we obviously wouldn't be able to populate anything there, but the standby will honor the in-memory flag for the alter table or create table command, and so then those objects will get populated on the standby. Then if you connect to the standby, you can run your analytics there, and you kind of have a nice little environment where OLTP or production workload isn't impacted by reporting. The standby, which is all it's doing, is in recovery mode. So now it can, with Active Data Guard, you can now run your not only normal reports, but your analytic reports as well. And then you can run, if you allocate the column store on both the primary and the standby, by default, if you don't set anything for the in-memory distribute for service command, will populate all objects marked for in-memory on both. However, if you want to use the distribute for service command based on services, and so in a rack environment, services are typically created with server control that define what applications can connect to which nodes or which databases. And so if you have a standby service and a primary service, then you can allocate objects either to the primary, to the standby, or to both. So we give you the flexibility to have objects in one or the other or both of the Active Data Guard environments, either your primary or your standby. So it gives you the flexibility based on the service, and then should the heaven forbid the primary goes down and you have to do a failover, then those services will still be honored. And if the services for the standby are used in the primary, or if just the primary services then become available, the in-memory clause will honor that. And so objects that were in the primary prior to the failover will be back in the primary after the failover. If you reinstantiate a standby and those services, then those services that were previously serving the standby then would obviously populate and be available again as well. So a lot of flexibility there, and Database InMemory works with all of Oracle technology and Active Data Guard as well. So with that, we'll move on to running Database InMemory on a subset of rack nodes, because by default, we'll populate across, as we talked about, we'll distribute across all of the rack nodes. So what happens if you want to only run on a subset of column stores? In this case, we have only 3 column stores on our 4-node rack cluster. I needed to put animation in here, and here's my animation for today. If I can get it to click on there. So very, very likely you may have only, say, you only have 1 column. Oh, there we go. You might have a situation that looks like this. Let's see if I can get rid of where you actually only have in-memory column store allocated on one of the instances. That's kind of the easy case to think about. So you might have a service, and I'll do that in the next slide, but you might have a service allocated for just a single node, and that may be the only place you want analytic reporting to run. So it's a little easier to visualize than having it, but it's very possible you can have one or more of the nodes, or you might have, let's see if I can do an undo here. You might have data in this node separate from the data in the node 1 versus node 2. So you give the flexibility very similar to what you can do with the primary and standby database if you want to run with a subset of nodes. So the question might become, well, why would I want to do that? One of the reasons you might want to do that is because if you run an EBS, eBusiness Suite, eBusiness Suite doesn't allow inter-node parallelism. And so we know from our previous session that if we want to access an object in the column store in Database InMemory, and we distribute it across the rack cluster, we use parallel query to access the data in all the nodes. But EBS doesn't allow parallelism to go across or internode parallelism. They only allow parallelism to run on a single node. And they use something called parallel forced local, which is a net.aura parameter, to ensure that happens, that you can only run parallel query on a single node. So that makes it a problem for database in memory, except if you can run database in memory in an isolated column store on a single node with a service allocated to it. Then you can connect to that service and run your analytic workload against your EBS system and be perfectly certified with that. So there is an actual white paper that we worked with the EBS folks on that's available on our blog and also on OTN. But I'll talk about the blog towards the end, and I'll show you some of the links. And so I've got that out there if that interests you. But basically what we're talking about here is wanting to run independent column stores or a subset of column stores for something we call application affinity, or when you might have a particular application, you're only connecting to one or maybe two of your rack nodes, and so you can now support the column store and objects in the column store on just those nodes and not have to use the entire cluster to access the data. And so that's very useful for some applications. So how do we do this? So we basically do the same alter table commands as we would for DataGuard. It's a distribute for service. In this particular example, we have, and I'll show you a setup where we have our 4 nodes. We've essentially named them IM 1, 2, 3, and 4, or IM 1, 2, and 3. And so we're going to allocate the customers table to one node, and we'll allocate the sales table to another node. And the syntax is essentially the same as what you're already used to. In memory, we're just adding a for service clause to that alter table command. You only have to do it once. Once you've altered the table, it's part of DDL, so it's part of the data dictionary. If you were to recycle the node or recycle the cluster, or to bring the database down, bring it back up, all of those commands are still there. You will then repopulate the customers and sales tables just as you had defined with that for service clause. And what this allows you then to do is to we described, you can have application affinity. You could have one application running on one node and maybe another application running on another node, and they can basically operate independently of each other but still take advantage of database in memory.
So Andy, just a quick question on that. If I'm doing this in memory with the distribute for service specified, and I have a rack node failure where that service is running, what's going to happen? So
the object will follow the service. So if the node goes down and all of the objects associated with that node's service or services would obviously no longer be available. Now, if you move that service then to another node, then those objects will follow the service basically.
So they could be populated in memory on the rack node wherever that service fails over to.
Right, which is different than normally when we don't use a for service clause, because in that case, obviously if you've distributed across the, say, 4 nodes, then, our example is then one node goes down, you lose 25% of the in-memory column stored data. If it stays down a long time, then we will populate that missing data to the other surviving nodes, assuming there's enough space in the column stores. But we do have a timeout, so that we won't do that immediately. If that, for some reason, that instance or node were to come back fairly quickly, we wouldn't want to move it all and move it back, because we will move it back once that node becomes available again, because obviously you don't want to run with 25% of your column store not populated once it comes back.
So in fact, this for service gives me better control about where the data would be populated in memory if there was to be a server or node failure.
Yeah, it does. But of course, it assumes that you have enough memory to be flexible like that. So you have to do a little bit of planning. But yeah, it does definitely give you the ability to. It doesn't allow you to because you still have to repopulate, but I have a little note here about the duplicate all or duplicate all command, and notice that that's an Exadata only feature. So it kind of gives you a poor man's duplicate, but you still have an outage that you wouldn't have if you were running Exadata and we're using either the duplicate or duplicate all option. But it does allow for relatively seamless recovery because it will happen in the background. I hate to use the word automatically, but automatically, where you don't have to have involvement in actually controlling that. It'll happen if you've set it up in the background, or if you've set it up, it'll happen automatically for you, and you can take advantage of that rather than having to endure an outage or manually having to relocate the object to a different node or service.
We also got a question on chat around this, which is, if I know I'm taking a rack node down, let's say for patching potentially, could this migration happen? Could I control when this happens? And I guess as you just said, the content of the in-memory column store follows the service. So you could drain the connections to that service, fail the service over to the other node and have it repopulate over there and then bring the node down. Is that right?
Yeah, exactly. So the key, though, is that you do have to drain the connections. And actually, you don't have to drain the connections if you don't mind. But as far as database in-memory is concerned, we will unpopulate. If you move the service, we'll unpopulate from the column store that the service was on, that you were populated in, and then we'll repopulate or populate to the new service or the new location of that service. So there will be a period of time where there's essentially the data is no longer available in the column store. But other than that, yeah, so that's how you could do planned maintenance fairly seamlessly. So the other example, independent column stores, and we'll talk a little bit about this. I have actually have a demo that will kind of look at how this works in SQL Plus in an actual rack environment. But the idea is that we might have an IM1 node and an IM2 node, two different nodes, two node rack cluster. And then we have an IM all service that would cover all of both nodes in this case. And so here we have the ability to place objects either in one node, the other node, or distribute across both nodes. And that's kind of the syntax that you would use to set up those services and start them. And this sets up the next slide, which then allows us to place, say, the customers table. You can see that in the first node here, our IM1 service there. And then the sales table, put that in our second node, or IM2 or node 2, and have those column stores act independently. And so services or connections then connecting to IM1 would be able to access the customers table in memory. Services connecting or connections connecting to service IM2 could then access the sales table in memory. Now, if you're connected to IM2, accessing the sales table, but you want to access the customers table, I'll have an example of that. You're not going to get it in memory. So in that case, you would need to connect to the IM all service to do that, to access both those tables in memory. And so that brings up the caveat that if you're going to do independent column stores, your applications have to be able to honor that independence. And so you can't expect to be able to connect to a independent column store and access objects on another column store because the population and connection will honor the service. So, hey, we're moving pretty good. So let's see the demo. Let's talk a little bit more about this, but with something real, if you will, rather than just slides. So I've got a VNC console here. You have to bear with me for the, hopefully we can see it okay. And yeah, I'm unfortunately gonna have to do a little bit of typing, so you'll have to endure that as well. But what I've got here is 3 different windows that we'll use. I'm connected to I'm in a environment with a rack database, 3-node rack database running. I've tried to duplicate as closely as possible the services both in this presentation, and then I'll have, we have a blog post that follows this as well, so that you can, it all kind of hopefully will make some sense to you. But let's take a look at, I've already set up services, and so the database itself, using server control status. So we're actually running 3 instances, 3 nodes, DB 18, 18.2, 18.3, and then what I should have done is I should have saved. Let's see what the services look like.
Andy, you've got a typo, I'm afraid. Sorry to be a backseat driver.
That's why I don't like to type when I'm, yeah, but that's such as life. You'd think being computer people, we'd be really good typists, but unfortunately in this environment here, I don't have a normal keyboard. So we have already our IM1, IM2, and since it's a 3-node example, we have IM3, each running on, IM1 only running on the instance DB18, IM2 obviously 2, and IM3 on 3. And then our IM_all runs across all 3 of those instances. So that's mirrors very closely the example we have in our slide. Oh, I just went too far. Fairly closely here, so we have a 3-node example rather than a 2-node example. But that's kind of the point, was we have this available to take a look at. And then what I'm going to do is I'm going to connect to one of the nodes, and I'm going to show you what's populated. So what we're going to do is I have a little script here that basically shows us, oops, what is populated in all 3 column stores. So notice that I'm looking at GV $IM_segments, and so I have instance ID. So we have the line order table, our normal SSB schema we use in all of our blog posts, our hands-on labs. We use a SSB schema. So line order tables, essentially our fact table, it's the large table. Notice that it's populated across all 3 nodes. I use the IM, in this case, I use the IM_all service for that. Then we have our part table is only populated on node 3. And then our supplier table, in this case, is only populated on node 2. And so I've created services, or I've said alter table in memory, part for service IM3, and alter table supplier in memory, distribute for service IM2. So I've associated those 2 tables with the single service. So in this case, if we wanted to say part might be like a payables application, and supplier might be part of a purchasing or inventory application, and those applications need to run separately so that the workload doesn't interfere with each other. So we might have those isolated to different nodes. If we wanted to run our normal star schema type queries, we would probably connect to the IM_all so that we could access all 3 nodes, and the column stores in all 3 nodes. Otherwise, we would be getting data. The queries would run, but we wouldn't get data from the column store we were interested in. So let's look at that example. So let's query since I connected to IM3, the node 3. So let's take a look at and query the part table, since it's populated only on node 3, and see what that looks like. And so in this case, I don't have to do much typing, because I created a script called part and ran pretty fast. All it does literally is select P category and count, so an aggregation from the part table. We're grouping by category to see how many values we have across how many parts across each category. And then how do we tell that we access the column store? Well, let's take a look at the statistics. And here we see that we did indeed, we have our IM statistics, we did our IM scan, some SIMD, which is good. And notice table scans IM is 1. And this mirrors essentially the work that Maria did in a blog post she did for us on this very topic, which I have in a pointer to in the next slide. So when we go back to the slides, but we can see that we connected to the IM3 service. the part table is populated in the node 3 or IM3 node, if you will, and we're actually able to allocate or access that data then from the column store. So now what happens if we were to connect to a different node? Because we know node 1 and 2 don't have the part table available to it in the column store if we connect to that service. So we'll run the same query, part, still runs pretty fast. It's a small table. And then we'll look at the stats for that query. Here, notice that we don't see all of our IM scan statistics, and we don't see our table scans IM we saw before. Instead, we're just doing a normal row store query or buffer cache, if you will. And so we weren't able to access that object in the column store. So if we go back to my query up here, whoops, I'm flying right by it, didn't I? So since the part table is only in node 3, we have to connect to a service that includes that node in order to access that data. And so that's the big takeaway or caveat to using connections, service connections to populate the column store and to run a subset of nodes. And so as long as you understand that, which hopefully you do now, then you can leverage this and the ability to then run with services in a subset of nodes, or either a single node or one. You can do this with more than one node. If you have a very large cluster, then you can segregate by multiple nodes, and it's very flexible as long as your connections and your applications honor the services that you've populated the objects in with Database InMemory.
So, Sandy, we have two questions.
Okay.
One actually, they're both for the query you ran on node 1 that doesn't have the part table. The first one is IM scan segments disk. You did get one IM stat there. Can you tell us what that means?
That just means that we went and looked to see where the data was. We have to go, there's actually metadata associated with the object. And so we went and looked to see where that object was. It realized that it couldn't access it, so it basically had to go to the row store to get that data, which is why we see physical reads direct and session logical reads. And then obviously our table scans direct read.
So it's effectively telling us that the database knows the part table's in memory, but it's not in memory on a node that this service is running on. So it's going to have to go someplace else.
Yeah, I didn't include the execution plan, but it would still be table access in memory full, but it knows it can't get to it, so it has to go. And we've got some other blog posts that describe that behavior as well, if that person would like to go look at that. But yeah, that's essentially what happens. Is it says, oh, I have to go peek to see whether it's in memory, it's not, and so then I go to the row store.
Okay, and that kind of answers the second question, actually. So where did the data come from? How did you get the part data if you couldn't use the in-memory columns? And I think
that's the beauty of Database InMemory, right? So even if you know, in this case, it's, well, we have it populated, but it's not available to other services that we haven't identified. But even say some of the objects weren't populated in the column store, that goes back to our mantra that says, you know, your queries won't fail. They just may not be able to take advantage of the speed of the columnar formatted data if you haven't populated that data. Or the other case, which we've talked about before, is that say you didn't have enough in-memory column store allocated, so we only partially populated the object. We won't give you an error. We'll go get that data from the row store. So Oracle Database is built, especially with Database InMemory, the feature, such that we'll still return your application code or SQL without errors, but if we can't take advantage of the column store, we'll have to go to the row store.
All right, sounds good. Thanks, Andy.
So let me flip back, because we did see the demo, and I have here a last slide kind of summarizing the for services subclause, if you will. Actually, we've talked about both application affinity, and we had the question about can I do a rolling upgrade in essence? Can I take a node out of for maintenance, if you will, and can I then allocate or start that service on a different node, and will the objects follow it? And the answer is yes, it will. And then in addition, we talked a little bit about data guard, but we do, that example I just showed you is also fully worked in, as I mentioned, the blog post that Maria wrote for us. And she actually, I think, has a video of that as well on her SQL Maria website, which we have a link to in that blog post. Excuse me. And in addition to that, we do talk about this in the in-memory guide. And so we do in 12.2 and above have our own documentation guide for database in memory. And then this session will be available on the AskTOM website. We talked about if you go to your invite, you can scroll down and this video will show up there as well. And then even on our YouTube channel, we have try to make data available to you. On our YouTube channel, what I've been doing with these sessions is I've been carving out the actual demonstrations, and so you don't have to sit through all of my talking if you don't want to. You can just go just to the demo to say, oh yeah, that's what he said. And so I can just see an example of it that way. And we have other videos there as well. Both Maria and myself have done a bunch of talking at on different topics of database and memory, and all of that's available on our YouTube channel. And all of that, I guess I should have had, I usually do that, I don't think I did. On our blog, which I have here, let's say real quick. On our Database in Memory blog, I kind of like to call our Database in Memory blog our portal. And you can see that we have different articles here. And on the blog, it's a little hard to, if you don't know where it's at, it's a little hard to find, unfortunately. That was changed on us. But we have our DBIM resources, DBIM resources. And in there, I tried to put a pointer to all of the resources we have available about database in memory. So not only white papers and documentation, but application information. By the way, this one here, the using Oracle Database in Memory with Oracle eBusiness Suite, does talk about running on a subset of nodes with the parallelism issues. So that's a good read if you're running eBusiness Suite and want to use database in memory. Lots of our videos here, and we've got our AskTOM Office Hours link if you forget where it is, and our Database in Memory YouTube channel if you want to go see those videos. So it's we put this information in multiple places, so hopefully you don't get lost and you can find that when you say, oh, I remember something, but I don't remember the details. I'd like to go back and follow up on that. All right, enough of that. I think in this will be posted as part of the AskTOM session, but I do have then again other links there as well, and that's our in-memory blog URL. So with that, do we have any other questions, Maria?
Not right now, but folks, please feel free to ask questions via the chat utility at the bottom of your screen, or feel free to unmute yourself if you'd like to ask your question live. Anything you want on database in memory.
There you go. Yeah, and not just the topic we focused on. If you have other questions, if you just want to just try it out and how do I get started, feel free to ask us. You have 2 database in memory experts that you probably can't stump, although I shouldn't make that a challenge. Possible, but certainly we'll try to point you in the direction, get your questions answered. So, don't be shy. Please feel free to ask any questions.
So I have a quick question for you, Andy. Just one that commonly comes up when we're talking about rack, especially when we talk about having an object specifically in memory on just one rack node. If I connect to, let's say I have a 2-node rack cluster, the table's in memory on just one rack node. I connect to the second rack node and I do a DML operation, an update of an existing row in that table. Does the change get propagated and populated into the in-memory column store? Does that all happen, or what happens basically?
It does. So in that case, since you're updating data, you're doing DML, you're doing it to the row store. And so rack, of course, is a shared, the row store is shared across all rack nodes.
Mm-hmm.
And so the column store, wherever it's running, whether it's running on a single node or across all of the nodes, will see that information change in the row store, and then it will pick it up and repopulate any change data or add newly inserted data into the column store, regardless of where the column store lives, because the beauty of Oracle database is not a sharded environment, it's a shared environment. And so the Oracle database data is available to all instances that run Oracle database.
Great, so no dirty reads, nothing like that. I'll instantly see it. Yeah.
Exactly. Database InMemory doesn't affect or change transactional behavior within Oracle database, which is a great thing.
Yeah.
Because we keep it transactionally and essentially simultaneously in sync. We know once you commit where that data, that you've changed that data, or you get a read consistent view of that data. And so none of the Oracle transactional system or characteristics ever change. That it's the same Oracle database, whether or not you have Database InMemory enabled.
Great. Looks like we do have a question now, triggered, I think, by something you just said. How does Database InMemory work if I do have sharding?
Actually, it works based on the shard. So it actually is fully supported with Oracle Sharding. And so if you have a column store on a shard, then the data that's populated in the column store is only associated with that shard. And so it works just like a single instance database would work. Or I guess you can have a rack shard if you wanted to.
Yeah, you can. Yeah.
Ultimate in flexibility. I've never seen one, but Maria is, I'm sure, talking about that as part of all of the database features that have come with all of the new versions. And so it works seamlessly. So, but obviously we don't, since it's a sharded environment, you're not going to have data from a different shard populated in another shard's column, so it would be limited to just that shard, but it will work just fine.
And of course, if you've got any other questions about sharding, there is a separate office hours exclusively for Oracle sharding that Nagesh runs, and he's fantastic. He knows everything there is to know about Oracle sharding. But as Andy said, there is no issue at all running InMemory or any other database feature on an individual shard. They are fully supported Oracle databases, whether they're single instance or a rack environment, as Andy said. So, yep, no problem at all using Database InMemory with sharding.
And actually, you bring up a good point. Since we've talked about rack, we've talked about Active Data Guard, we've talked about Parallel Query, all of these Oracle technologies that Database InMemory leverages as part of Oracle Database. And there are AskTOM sessions for all of those topics. So if this is, well, gee, I need to, if this has maybe made you think of, maybe I need to learn a little bit more about rack, or maybe I need to learn a little bit more about Parallel Query, then go to the AskTOM website and pick up those sessions as well. So this is all kind of, I don't want to say, it's all integrated as a total solution. And so there are other technologies that we're not necessarily experts in, but that there are people who are, and there are sessions for those as well. So that's a kind of a plug for other AskTOM sessions as well.
Yeah, sounds good. All right, let me see. Folks, don't forget, you can ask your questions via the chat or simply unmute yourself and ask your question live. Andy and I will hang out for another couple of minutes to see if there's any other questions we can help address. But while we wait for those, Andy, I'm guessing that with Open World rapidly approaching, we'll be able to get more information about Oracle Database InMemory at Open World?
Oh yeah, we'll be at Open World. If you're curious about some of the new 18C features that are now that 18C is on premises or in the cloud, we have our normal hands-on labs. So we're going to be we'll run a hands-on lab each day. So if you want to come get your hands on it, it'll be updated. We'll have a couple 18C features available for you to play with, in addition to, of course, the 12.2 and the normal Database InMemory features. It's actually run such that you can have your own image of Oracle Database and Database InMemory to play with. In addition to that, we'll have numerous sessions. So I think I'm doing a best practices and implementation talk. We have Tanker, who's the Vice President of Development, will be doing a talk about where database in-memory is headed and all of the new technologies that they're investigating. We have Raj also talking about some use cases and customers, and so we have lots of information will be available. We'll post on our blog specific sessions if you don't find them in the catalog. And the only thing I would encourage is usually the hands-on labs are pretty popular. So if that interests you, I would strongly suggest trying to get into that as early as possible. Don't wait until maybe you're at the conference although I do try to allow people to kind of hang out in the back as long as they don't get kicked out for exceeding the room capacity. But the takeaway there is you really should try to register as soon as possible. And if you want one of those sessions, put that in your, the content catalog or the schedule builder, basically. So.
Cool. And any chance I could come and torture you or some of the in-memory developers in the demo grounds? Will you guys be there too?
I forgot about the demo grounds. Yeah, that, of course you can always come. But so yeah, I'm glad you reminded me that we will have a demo grounds. I think it's in Moscone South this year.
That's right. Yep.
We have another demo, the temperature demo that we did last year. There's actually a video of it on our website, but you can actually come in and do it on your own. You can actually come in and do it live. It runs on an Exadata machine, so you get to use a lot of great technology. And so we'll have developers there as well. So if you have questions or want to speak to the actual developers of database in-memory, those folks will be there as well. So come look for us. I think we're going to actually be with ×10, so we'll have all of our in-memory technologies together. And so, which we have 2 products that are a little bit different, but are leveraging in-memory technologies. So definitely stop by the demo pods as well.
Awesome. We're very grateful for you all joining us today. And as Andy has said now multiple times, you can replay all of the sessions that we've had in the Database in-Memory Office Hours by going to Ask Tom and just clicking on the Office Hours website, or by following the links that were in the email reminder you got today about today's session. Andy, any closing comments?
Actually, my only closing comment would be if any of this is of interest, if you want to make use of database in-memory, my email address is there. Feel free to email me. We'd be more than happy to provide any information for anyone who either is just starting out or has some deep dive technical questions. Really, our job is to try to get folks to make use of database in-memory. So please don't be shy.